Okay, Bismillah ar-Rahman ar-Rahim. Today we are going to talk about Chapter 6, the time value of money, and we will focus on annuities. In the previous chapter, Chapter 5, we discussed and analyzed the time value of money, but using one single payment. So the difference is today we are talking about annuities. We will focus on annuities. In Chapter 5, just to remind you with the Chapter 5, we invest one single payment for a particular period of time. For instance, for 5 years. Or we discount a future value one time today. So what is the future value in this case? What is the future value for a particular payment paid just only one time at the end of the year 5? Or we can talk about what is the present value for the payment is coming after 5 years today. So I talk in Chapter 5 about one single payment. Either we talk about the present value or the future value. But today, I'm focused on the annuities. What it means, annuities, and why we are using annuities. Annuities is paying or receiving payments or regular payments or equal payments for a limited period of time. You are receiving or you are paying payments for regular payments for a period of time. For instance, if you look at this timeline, we have 1, 2, 3, 4, 5, 6 years. And if you receive $1,000 each year, so this is called annuities. This is called annuities. If you are received $1,000, so you see here we have regular payments. Yeah, we have equal payments. But if we have streamline like this, 1,000s, 2,000s, 1,000s, 3,000s. So this is not annuity, or this is not regular annuity. Okay? So we solve this problem out by using different equations and different formulas. But the idea is here, the annuity is you are receiving or you are paying payments in limited period of time. So it is in 6 years or 10 years or 15 years. And the payments are regular. So the question is why people using annuities? Why people using annuities? People in annuities, if they want to buy houses, or if somebody want to buy a house, and this house is after 10 years costs $50,000. So how much you have to pay regular payments in order to secure this house? And another example, now you are in your bachelor degree and you want to go to the MBA, to study MBA. So what are the payments that you have to save in order to cover the MBA tuition fees? If the MBA tuition fees is $10,000, so how much you will receive per year in order to secure the tuition fees of the MBA? Okay, so and banks using annuities to amortize loans. If they give loans for customers, so how much the customers will pay the installments? Let's say, if the loan is $100,000, so how much the customers pay regular payments to recover the $100,000? For instance, they may pay $1,000 for a limited period of time, or $500 for each year to recover the $100,000. So this is the annuities and the applications of annuity. Learning objectives of this chapter. Annuities. We should know different types of annuities. Perpetuities. The difference between annuity and perpetuity. You know the difference between annuity and perpetuity? Annuity, as we explained before, it has limited period of time. For instance, here 6 years, 10 years, and so on. But for perpetuity, for unlimited period of time. We invest in a particular investment for infinity. Okay? For instance, you are investing in الوقف. نستثمر في الأوقاف. مثلا في building نحط فيه استثمار ما لا نهاية. يعني كأنه واحد شارع عمارة and he or she doesn't think to sell this. So it is perpetuity. So this is the difference between the perpetuities and annuities. So perpetuity is unlimited period of time or unlimited payments, but here we have limited payments. Number 3, complex cash flow streams. Complex cash flow stream, it doesn't follow the annuity. As I said, you receive $1,000 in the first year and $1,500 in the second, and so on. So this is not follow the regular payments. So before you are sorting the problems, you should think whether this is annuity or perpetuity or complex cash flow streams. So put your mind whether the stream cash flows follow the annuities, regular payments, or unlimited period of time, or complex cash flow streams. The objectives of this chapter to distinguish between ordinary annuity and annuity due. So what is the difference between them? Take this example here. 1, 2, 3, 4, 5, and 6. So we have here the year 1, year 2, year 3, year 4, year 5, and year 6. The payments either coming at the beginning of the year or at the end of the year. If the payment coming at the end of the year is in here, so it is known as ordinary payments. If it's coming here, if it is coming here, and so on. But if the payment coming at the beginning is here, so it is due. Now, from the mathematical point of view, or from the investment point of view, what is the difference between ordinary and due? There is a big difference between them. Because in the due, we have more space to invest our money. But in the ordinary, we have less space or less room to invest our money. Take this example. For instance, here, you deposit $1,000 each year for 5 years. Consider the case is ordinary and another case is due. See the difference now. Okay, we have 1, 2, 3, 4, 5. So we have 1,000 here in 1, 2, 3, 4, 5. So we have 1,000s, 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 and 1,000s. Okay? If we're thinking this is due, this is ordinary, so the payment is coming in here. So how long it takes to invest, this is the first $1,000 for 5 years. Okay, we use the, our information from chapter 5. So this is $1,000 invested till 5 years. So how long it takes? 1, 2, 3, 4. So to calculate the future value is 1 plus I times n. So I is the interest. So the n is in here is 4 years, because 1, 2, 3, 4. And you do the same future value 1 plus I power 3, and here future value 1 plus I power 2, and here future value 1 plus I power 1, and here it is the future value is equal to the present value, because 1 plus I power 0, which is 1. Okay? So just picture this case and see if this is ordinary, see if it is due. If it is due, take the same streamline, okay, starting by 1, 2, 3, 4, 5. So here is 0, 1, 2, 3, 4, 5. We're starting from here. So we have 1,000s, 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 1,000s. So 1, 2, 3, 4, 5,000s. And when we invest this, invest it for 5 years. So apply the formula 1 plus I power 5. Because you have 1, 2, 3, 4, 5 years. But in this case here, we have only 4 years. If you compare between this streamlines and these streamlines, or these cash flow streams and these cash flow streams, so here it's raised to the power 4, but here is raised to the power 5. Go to the second one. It is future value 1 plus I, 1, 2, 3, 4. Take the third one, future value 1 plus I raised to the power 3, future value 1 plus I raised to power 2, and this is the future value 1 plus I raised to the power 1. So look at the difference. If you look at the last stream here, it is $1,000, but here it's coming in the beginning of the fifth year, but we have 1 year to invest. So future value 1 plus I and the 1 year. So we have more room, or we have more space to invest our cash flows. So this is ordinary, and this is due. Any question related to this? For the formulas here, and you observe we are using the formulas in chapter 5. We calculate the future value for each payment. And because this is regular payments, we can apply the formula is future value for annuity. Future value is equal payments, these payments because are regular, 1 plus I power n divided by I minus 1. So this is the formula. Okay? This is the formula for this. And what the difference between the is just adds 1 plus I to this formula. Okay? So we will see. Okay, so we know the difference between ordinary annuity and annuity due, and calculate the present value and the future value. We talk now just about the future value. The present value, if we receive a payment in the future, what is an annuity? What is the present value today? If this annuity, if we are paying regular payments. The second, calculate the present value of a level of perpetuity and a growing perpetuity. If the perpetuity is growing, okay, if we receive $100 for unlimited period of time. And if we receive $100, and this is grow by 6% for alpha or for infinity. Okay, as I give you example in the in Islamic finance, we have something known al-waqf. Al-waqf, this is for unlimited period of time. So if we invest in al-waqf, it means we don't have a limited period of time for the investments. So we receive each year a particular amount of money for infinity. And if this is growing for a particular growth rate, so we will see how we can handle this problem. In traditional finance, we have something known as perpetuity bonds. Perpetuity bonds paying interest for unlimited period of time. Okay, for the bondholders. So it has many applications in the real life for this. Number 3, calculate the present value, the present and future value of complex cash flow streams. If we have irregular payments, how we can treat them. The principles apply in this chapter, and we discussed it chapter 1. Money has a time value, and cash flows are the source of value. And in your exam, I asked you about the difference between profit maximization and the wealth holder maximization. Wealth holder maximization is influenced by the cash flow, by the real cash flow. Because investors, they are looking at the cash flow streams, and they evaluate their business based on the cash flow or the expected cash flows. Let's start by in details in annuities. Annuities is a series of equal dollar payments, regular payments, that are made at the end of equidistant points in time, such as monthly, quarterly, annually, or over a finite period of time. If payments are made at the end of each period, the annuity is referred to as ordinary annuity. See this example here. How much money will you accumulate by the end of year 10? So when you are answering or handling the question, to be a professional, I think it's fine to have this margin space here and to write the information that's coming from the question. It's important. And to try to think what is the examiners will ask you. This is a good approach, just to try to guess. How much money will you accumulate by the end of year 10? So we have N is equal 10. Just do like in this way. If at the end of year 10, if you deposit $3,000, is this future value or this is payment?
Present.
This is present value or payment. So this is the payment. The payments, and this is annual payments and regular payments, because in your exam, let's see, in the final exams, the examiners is not state for you, this is regular payment, this is annuity, or this is not annuity, this is complex cash. No, this is not, it is not as simple as you think. You try to make your mind up, to think how you treat the question. So the payment is $3,000 each year for 10 years, so we have 10 years, in saving account that is 5%, so I is 5%, okay? In a saving account that is 5%. So how much money you will accumulate? When you know what it means, accumulates, it means the future. What is the future value? So we need the future value. What is the future value? Now, before asking or answering this question, I want just to bear your mind to this thing. In questions, we have options, many options. I may give you the N or the payments, and I ask you about future value. Or I may give you N payments and ask you about the I. Or I may give you N and I'm asking you about the payments. Or the last case is I'm asking you about how long it takes to invest a particular amount of money at a particular interest rate, and the future value is X. So this is the options of the questions. I may ask you to give me the future value, or what is the interest rate, or what is the payment, or what are the payments, or what is the number of periods. Consider this case. Okay? So in this case, we're asking about the future value. So the formula is the future value, and this is, careful, this is annuity. This is annuity is equal the payments 1 plus I raised to the power n divided by I minus 1. This is the formula here. So just apply the payment. We have payment $3,000. Well, this 1 plus I is 5%, so 0.5 raised to the power 10 minus 1 divided by 0.05. So the future value is, let's see the answer in here. As you see, this is the, okay, and it is $37,740. Okay? If you have the financial calculator, you can use the N and in this way. Or using Excel, using the future value, both the rates, and peer and payment, present value. Now, okay.
The end.
Sorry, go back here. How much money will you accumulate by the end of the year? 10. If you deposit each for the next 10 years in a saving account that earns 5%. Okay? Solving for payments, now I'm asking about payments. In the previous question, I asked you about the future value. Now I'm asking you about the payment. Instead of figuring out how much money you will accumulate, you may like to know how much you need to save each period or each payment in order to accumulate a certain amount at the end of any year. At the end of the year. So when we are using at the end, it means we are using ordinary annuity. In this case, we know the values of n, I, and the future value in equation. And we need to determine the value of payment. Take this example here. Example 6.2, suppose you would like to have 25,000 saved 6 years for now to pay towards your down payments on a new house. So 25,000 here is not payments. This is future value. Suppose you would like to have 25,000 saved 6 years for now to pay towards your down payments on a new house. I gave my student last year a question looks like this. But the problem is just only 1 or 2 students answered this question. What I've done is like the house is equal worth $100,000. It is worth. Okay? But you have money you will pay for the commercial or for the traders 35,000. Okay? And the rest you will pay them by taking loan from bank. So what we can do in this case?
نعمل deducted لل 35 30,000 من 100,000 مش غالبا.
Yeah, so what is the future value that you will pay?
75,000.
Yes, no, 65,000. But most of the students sort out by taking the $100,000, not this. Because here you already paid 35,000. So be careful this in this case how much you will invest in your money. Okay. So suppose you would like to have 25,000. So the future value is in here at 25,000. Okay? If you are going to make equal annual end of year payments, careful. End of year payments, not only one payment, it's payments, to an investment account that pays 7%. So investment account 7%, and we're asking about payments, we don't know the payments, and N is for 10 years, for how many years? 6 years. So N is 6 years. Now, again, the future value is equal to the payments, okay, 1 plus I raised to the power N minus 1 divided by I. So this is the formula here. We know the future value is 25,000. We don't know the payment. We know 1 plus I is 0.7 raised to the power 6 minus 1 divided by 0.07. Okay? We know the payment? No, we don't know the payments. So we're asking about the payment. Very simple. Just do the calculations of this, then divide it by 25,000 and the calculations of this. You get the payment. You see here, future value, this is the same formula here, 25,000. We don't know the payments, and here this is the calculations of this factor. This factor is 7.153. Just divided the 25,000 divided by 713. You have to pay $3,495 each year to get $25,000 after 6 years. Okay? Okay, double check this. How much must you deposit in a savings account earning 8%? Okay, so it's I is equal 8%. Annual interest, it is annual interest. In order to accumulate $5,000, accumulated means future. So the future value is $5,000. To accumulate $5,000 at the end of 10 years, so we have N is 10 years. Let's solve this problem using the mathematical formulas. So we have I, we have future value, we have N. What we want? The payments. Similar to the previous one. So the future value, again, future value 1, future value is equal the payment time 1 plus I raised to the power N divided by I minus 1. So it is the payment, we don't know the payment. 1 plus I is 0.8 raised to the power 10 minus 1 divided by 0.08. Just very simple, do the calculations here. 5,000, just carry on. $345. 0.15. Okay? So as you see the payment, and you get $345. If you have the scientific calculator or financial calculator, this is very simple. You can do it. Anyone using the financial calculator? No? Okay. And you can use Excel sheet as well. Okay. So far we talk about if we don't know the future value, if we don't know N, and if we don't know the payments. Now the I, this is much complicated because we need to do like try and error. It's not like the in chapter 5. It's not the same things. You can also solve interest rates you must earn on your investment that will allow your savings to grow to a certain amount of money by a future date. In this case, we know the values of N, we know the payments, we know the future value, but we don't know the I. We don't know the interest rates. So take this example here. In 20 years, you are hoping to have saved $100,000. Is this payment or future value?
To have saved
Accumulated.
Future.
Yeah, it is future value. Towards your child's college education. If you are able to save 2,500 at the end of each year, so this is the payments, for the next 20 years, this is N, what rate of return must you earn on your investment in order to achieve your goal? So we need I. C, using the mathematical formulas. We know the future value, we know the payments, we know the N is 20, and the same 1 plus I divided by I, but we don't know the I. So in this case, what we can do, the first thing, just 100,000 divided by 2,500, so you get 40. This is the first. Then you have to solve this. In order to solve this right-hand side must equal the left-hand side. This one must equal 40. So what we can do is the try and error. The try, for instance, 10%. The strategy is try 10%. If this greater than 40, try by interest rate less than 10%. Okay, and so on. And for advanced finance, we can use particular formulas to sort this out. But in this case, in your level, you don't need to apply these formulas. Okay? So in a particular, we can use formulas to solve this problem out by using mathematical solutions. But we can use Excel sheets. Okay? We can apply Excel sheets. I will show you how we can apply Excel sheets. So using Excel, so in the Excel sheets, go back to, we have to use formula known as rate. My student in financial analysis, they will apply all of these equations, but just to know how we can use it. Use apply rates, apply formula rates. So what we want to know, the ampere, okay, and we want to know the payments, and the present value, and the future value. So the ampere is the number of payments, how many payments, for how many years. So we have 20 years. Just apply this in the margin to see how you can apply. The payments is 2,500. The present value is today is 0, and the future value is $100,000. So this is the formula. Okay, see how we can apply this in Excel. Okay, I think you are familiar in Excel because you have Excel. Okay, so the first one is ampere.
20.
So how much here, ampere?
20.
20. Okay. And the second is PMT.
2,000.
So PMT how much?
2,500.
500.
Then
BV
0.
0.
The
Future value is
100,000.
100,000. Okay, just to make things clear. Okay, so if we have 100,000 in here, so what is the formula that we will apply? The formula is known as rate, just to remember this. So it's equal rate. You can apply the formulas by just filling these things, the factors, or by doing the functions. Put in the functions. And here, ampere, the number of payments is this. The payments is this, 2,500. The present value is 0. The future value is 100,000. Okay. And the result is this. Okay, let's go back. It should be, the type is, it should be like this. 100,000. Okay. Is equal the rate. The payments, this, the ampere 20, and here the payment is this, and the future value should be this, and the type should be 0 or 1. I don't know why the problem here. So this is the number 20, 2,500, 0, 100,000. I don't know what is the problem. Okay, so let's again the rates 20 مظبوط. Retains the interest rate period. Okay. The payment. Okay, yes. The payment, where is the problem? The payment must be minus. Okay. Why it is minus? Because it is cash outflows.
Oh, okay.
Yeah, this is the things. And okay. And you can do the format cells. We will do it again. And it's 5.85%. Okay? So why it is minus? Because it is cash outflow. We saved. So the rate is $100,000. If you do this minus, okay, we want to do it again? Well, that's it. Okay. Why it is here 6.7%? We'll double check. Okay, take this example, another example. Oh, this is not 5,000. This is another example, this. Oh, okay, okay, see. Okay, let's take another example here. Solving, suppose you are investing $6,000 at the end of each year in an account that pays 5%, how long will it take before the account is worth $50,000? This is very simple. Okay, so what we want in here to know how long it takes. So we need to calculate N. Okay, we have to calculate N. So we apply the formula here. In this case, the same formula, the future value is equal $50,000. The payment is 6,000. I is 5%, and we want to calculate N. Okay, so we will leave this question for the next meeting, and we will answer this. Okay, إن شاء الله نشوفكم اللقاء الجاي على أساس نحل هذا المثال. Okay, يعطيكم العافية.